David will present us with ideas and solutions on how to design reliable and reproducible machine learning pipelines. David is currently the head of open source machine learning strategy at Microsoft. He has a very impressive and interesting career that took him through a mixture of startup and enterprises. All somehow are involved with open source, DevOps, and machine learning. Prior to Microsoft, he was a product manager at Google, specifically in the Cloud AI group, where he co-founded Kubeflow. Many of you might have already heard about his work or heard about him. He's a great presenter. No pressure, David. Before that, David was a chef, another iconic open source player here in the area in Seattle. He's super involved in the open source community, not only through the nature of his day-to-day work, but to me, it seems like he's just super passionate about open source. The idea for this specific talk came together when David and I were discussing one of his new personal endeavors and passions, which is around metadata in machine learning pipelines. And I am thrilled to have him here today to share his wealth of experiences, open source packages and ideas, and some of his projects that he's working on. So I will stop sharing and give this over to David.
Thank you. That is far beyond what I deserve. I really appreciate it. I really appreciate the opportunity to come talk to you all and kind of talk about some of my experiences, things that I've seen go well for customers, and you know what I've seen work when it comes to building reproducible pipelines. And I'll be introducing a library that I wrote. It is you know, just me doing it, and I hope you find it useful. Ideally, we can collaborate and work on it if it solves some real problems for you. Anyhow, so I should also do housekeeping note. I'd love to, at the second half of this, if we are able to find Victor, demo some of the work that he's been doing around MLOps. It's really transformative stuff around reproducing benchmarks. I should also talk about using chat. Feel free to drop lines in chat, whatever you like. I have about 15 minutes of slides, and then we'll get right into demo. With demo, don't even bother to chat. Just ask questions right out loud. It's totally fine. Okay. So with that, let's dive in. You know, I do work at Microsoft. It'd be a mistake if I didn't point out like how much we do machine learning at Microsoft. We're really proud of the things that we do. We give a ton back via Microsoft Research. We use this stuff internally. Many of the cognitive services you see hosted on the Microsoft platform are built with these technologies. And you know, you see this all over the place, right? This is one of the reasons I'm so passionate about machine learning in open source, is these things all flow back to the community. So Microsoft has one of the largest research arms in the world, yet we're always giving this stuff back. So, you know, better than human comprehension for all these various things, machine translation and so on. And then people build on top of our work and go out, which is exactly the point of open source. Just about every product at Microsoft uses machine learning in some way. Truly, you know, we could not get to the scale that we have right now without automated ways to process through data, enormous amounts of data. But when it comes to the real world, what you see is basically this: machine learning is hard. And the reason is because of what you see here. You know, we spend so much time focusing on just building a model that we leave off the rest of it. And that is basically everything around it. Machine learning is really about pipelines going end to end, rather than just building a model. Downloading, running a Jupyter notebook, that is great. But if you don't focus on the actual building of the entire infrastructure, you're going to run into a lot of trouble. Now you say you're a data scientist, and I don't care, you know, I can figure it out myself. But the reality is you do. And the reason you do is exactly what you see here, right? You know, this kind of story is reproduced over and over and over in the industry. It took us 3 weeks. We got a fantastic model, you know, better than human performance across some new translation or other app. but when it comes to actually using it and getting it out, it'll be another 11 months, and it's still sitting on some dev's desktop. And one of the reasons is what you see here, right? A data scientist might exist on the left-hand side, where they're looking for quick iteration. She wants to use the latest frameworks. She wants to use things that she's familiar with, all that kind of good stuff. And excuse me, on the right-hand side, you see the SRE. She's looking for reusable tools. She's looking for structure. She wants governance and enterprise requirements. But we can bring them together. And the way to do that is through something like MLOps. So MLOps, the idea is that data scientist exists on the left-hand side. She's experimenting. She's going through that inner loop. She's building as quick as she can, looking for quick results and understanding. But then when it comes to folding into the rest of the application, you go through additional loops of DevOps, where you are building out model testing and other frameworks, continuous integration, and then finally rolling it out to production. And this kind of process where everything is looped together is the essence of MLOps, and it will help you bring your model to production faster. So you say, a pipeline, fine. What does a pipeline look like? Well, it looks like this, right? You'd have that data scientist over there. She begins her process and she says, wow, here I'm popping up a tensor board, looks fantastic. Accuracy, average loss, all the metrics up and to the right. This is good times, right? So she says, I'm going to go to production. She checks it into Git, like so many of us do, pushes it out to production, and bad things happen, right? And the reason is, who knows, right? You literally don't know the reason. I have some examples of reasons right here, right? This was an amazing exercise. I took this and I literally went out to Twitter and I said, hey everyone, I have a couple of ideas of where models go wrong. What do you think of this list? And the rest of the list just filled up almost instantly. It's crazy, right? Wrong drivers, wrong space, wrong permissions, couldn't figure out how to go from A to B. Nobody had documentation. The model drifted. I was going against the wrong schemas. Oh my God, it's like insane. And we ask data scientists to take this on. And the SREs as well, right? It's all a disaster. And you have no idea why. The way out of this is with clean pipelines, right? And so we go back to our data scientist and she checks it in, but instead of it going straight to production, you have a structured pipeline that walks through exactly what's going on. And so you say, well, I'm going to use this to standardize clean. I'm going to execute some automated validation profiling, so on and so forth. I'm going to look for bias using any of the number of public bias tools. I might package for rollout in some standard way, including things like drivers and things like that, be able to smoke test it before I get out there, and then do some form of sane deployment where you can canary it out, make sure it all works before you eventually expand it and go bigger. And then everyone's happy, right? Now you say, well, I can do all these manually. I'm going to have a big, long checklist. And the reality is, no, you can't. And the reason I say no is because even if you trained every data scientist and you had all the tools necessary, they were all working together and all the SREs understood ML to the same degree your data scientist did, and you still need a reproducible permanent record of what you did, right? And that is what metadata is. And that's what MLOps gives you. If you drive your entire workflow using nothing but structured metadata, now you have a reproducible event of exactly what happens. So, people ask, well, you keep saying this word metadata. What is metadata? I like to point at this and say, metadata is the stuff in between. It's a contract that describes how to leave one step, what happened during that step, and then what you pass on to the next step. It's also a historical record because now you have this recorded. It's structured, so you're able to go and probe it using automated tools and steps and things like that. And that all together, plus more, is how you start to get reliable pipelines. Because now, if you're not driving it by having some random dev log into a VM to SSH in and execute something or release it or whatever it might be, that never gets recorded, now you're able to drive things forward reliably. So an example of this, and I just, call out this came, live from a production example, might be something like this. It's just YAML. But in this case, it says exactly what base image I used, how many CPUs, per node there were, what the build SHA was, what machine type it was, what the output path was. There are all these various things that you're going to want, and your ability to capture them and record them make all the difference in the world for building these reproducible pipelines. Okay, so I haven't convinced you yet. Now I'm going to really try and scare you. Over here, you have this SRE. She's doing great work. She has a front end with a model server. And on the right, you have your customer. She's just coming along. And she says, I'd like a loan, right? Standard request. And the front end of the service says no. And the customer says, well, why? And the SRE says, uh-oh. And the reason she says uh-oh is because lawyers, right? This should scare all of you. It's real, right? Unless that SRE can say unequivocally why that customer was denied that loan, and to make absolutely sure it wasn't because there was a violation of protected class, her PII wasn't violated, there was a standard procedure for executing, you're going to have a date with a lot of lawyers. And it's not just about explainability, right? Understanding the details of your model is important, but it's everything else that also is included. What data did you train on? How did you filter the data? How did you, oh, these were outliers. How do you prove that those are outliers and that you didn't train on them? What are the statistics? Did anything change between when you trained and you rolled out to production? That happens all the time. And especially in ML, where literally changing the drivers can change the way that you do inference. And then, what model did you actually serve to this person? When you, go back and look at that user ID, what did she actually get her result from? This is where metadata can help. And so now what you do is, as an alternative, is something like this. You say, okay, I'm going to use that pipeline like I was expected, and then I'm going to sign every single one of those steps, every single bit of metadata, I'm going to sign that. And then I'm going to sign the whole thing as a unit and put all of that into a single immutable store. And once I do that, the customer comes back and says, well, why didn't I get a loan? You can say, well, it was this particular SHA that was the one that gave you the result. Now, again, that doesn't necessarily absolve you, but without this kind of metadata and structure, good luck. You're going to be in trouble. So like I said, metadata gives you a bunch of stuff, what you trained on, how you transformed it, all this kind of stuff. But if you're using metadata and MLOps, you get a repeatable record automatically, mostly. It does take a little bit of work. So now you're saying, well, you can't possibly expect me to use YAML. And that's where I'm going to introduce ML-spec-lib. This is the library that I wrote. I'd love it if this was interesting to all of you. And it's certainly my view of the world. There are many other ways to approach this, but my hope is that we're able to help people move forward in this very simple way. So it's a simple Python native library for working with schematized objects. I didn't write it all myself, certainly. That's what I love about open source. I extended Marshmallow, which is a very popular open source schema library. But it's very ML specific and very Python first. It does come with some standard schemas in the box, but I'll be honest with you, they're just my creation, so I'm not expecting them to work. And it does start with ML, but it really does work for anything. And I'll show you how easy it is to use in just a second. There's more. You can read and write serialized objects natively. You don't have to ever touch Python. You don't ever have to touch, YAML. You don't have to touch JSON. It supports both. But under the hood as a serialization format, not as the surface that a data scientist will be engaged with. Ideally, and my hope is that it's very usable and friendly. It is trivially extensible. I'm going to show you how to do that, including pulling from a remote store. So if you have your own schema that you want to extend it with, and it's just hosted on GitHub, we can do that. It also does lazy enforcement. So if you have an object that's going to change many times, it's okay to instantiate it once, and then only when you save it or try and serialize it will it do enforcement, which is something that you run into a lot. And then it does code gen for the really, really lazy like me. I actually, at some point, I literally wrote this function because I got so tired of writing the YAML myself for testing purposes that I was like, I'm going to use CodeGen to do it for me. Okay, so enough talk, get to the demo. Okay, so can y'all see this?
And maybe questions if there are any?
Yeah, go ahead.
I don't see anything in the chat, but since we're jumping into the demo, if anybody has questions, please jump in.
Quick question. First of all, hi. Quick question is that the metadata, right? How are we storing it? Are we storing it in a text file or a SQL file, or are we having a separate server running where we can actually go and get the data, GitHub file? Like, how are we storing the metadata to be accessed?
So it's really up to you. My recommendation would be to store it in you know, an immutable store.
Okay.
So you know, it doesn't matter. You could easily store a JSON blob or YAML or text file or some binary format. I truly don't care. Whatever you use, though, it should be compatible with the libraries and the tooling you have for all the other infrastructure that you're using. So if you're a Go shop, you better make sure that you're able to read and write that metadata programmatically, and particularly around your pipelines. Now, that said, obviously, if you serialize to something like YAML, that's literally supported in 100% of formats. That said, you know, I do get a lot of questions around stuff like, well, you know, I associated with my metadata, I have these very large blobs. What do you want me to do with them? My recommendation is for that should not be part of your metadata. That is actual artifacts and things like that. What you want to do is fingerprint that blob in a you know, a cryptographically secure way, record the SHA and record a pointer to it, and then write that off. Another question I get a lot of is, how do you deal with things like data diffing and things like that? Do not try and solve that problem yourself. It is a very complicated problem. There are wonderful open source projects like Apache Data Lake, or excuse me, Delta Lake, which are supported by most of your major data platforms, that will handle the diffing for you and give you a SHA or some form of a hash to unequivocally be able to regenerate that data into the future. But recording that stuff, really don't try and tackle it yourself. Diffing is a known, very hard problem because there are really only two solutions. Either one, you have a platform that supports this, or you just spend a ridiculous amount of disk space because, you know, if one byte in one file change, you now need to make a duplicate of the entire thing. So that's the broad strokes. Does that answer your question?
Yeah, that does. Thank you.
Sure. Okay. There's another question. Does it support JSON schema? It doesn't yet. It just supports JSON and YAML. The truth is, I actually was really interested in using JSON schema. To me, it felt very web-centric. That and OpenAPI both felt very web-centric. I don't care. I would love to tear out 100% of my code if someone came along with something else. But you know, it's up to you. Those credentials are not real. This comes straight from the AWS site. You can see here, example right here, an example right here. They have sample ones that match their pattern.
They're there to make sure that somebody's paying attention.
Yes, very good. Okay, so if you are like me, you have seen many of things like this in the world. This is what I call a data, you know, arbitrary structure here, a data path, where I'm storing some stuff on a blob somewhere. Here's the name of my data store. Here's the S3 bucket I'm dropping it into. It doesn't matter what. But this is a perfect example of something that I might start my pipeline with. I'm going to store it on this, you know, this S3 bucket endpoint with these credentials, and this will kick off my overall training run. Okay, so the problem is that YAML like this, text like this is very easy to get wrong, right? Like, you know, maybe I, you know, had a mistype here, and all of a sudden, you know, I'm missing an S. Well, what happens? Well, unless you have a structured way to read and write this and verify that the schema is correct, you know, human beings are really going to make these errors, and you know, your pipeline might fail, you know, 17 steps in without you even realizing what the cause was. So my idea was, how do we develop a system, a library that will enable trivial checking of these components, you know, in a Python and data scientist friendly way. So what I did was I wrote a library that is designed to allow you to describe the enforcement, and you only have to do this once, but describe what the structure of the schema looks like so that the library can move forward. So you have to do a few things here that, you know, at the start. You have to say what type it is and what version, and give it a name and so on. But outside of that, it's really straightforward. Here I am. I'm defining that, you know, data store, that field that you saw there, is a string. It's required, and it cannot be empty. Here you can see data store or storage connection type. This field here comes from a named list. We support named lists, and here it must be one of these. Here you can see it supports nested versions. Here it's looking for connection, and inside connection it needs 3 fields. This is what that looks like. It says it's nested. Inside that it has 3 fields. Has a type of URI. We support that. We support things like regexes and things like that, all for verification. Okay. And it does support very complicated things. Here, you know, it supports things like run configs, and here you could support things like lambdas, where, you know, you can say, hey, this field needs to be larger than 4,000, for example, so on and so forth. But, you know, this is a lot of, you know, text in front of you. How does it actually work? Well, let's check it out. So can you all see this? Okay, good. So here we have a sample notebook, and all I'm going to do is I'm going to import MLSpecLib. MLSpecLib is hosted here on a GitHub repo, wide open, and it is you know, also on PyPy. And I'm going to import some things here. I'm going to import more than you would actually need. You don't need more than MLObject, but I'm going to import more because I'm going to show you some stuff under the hood. But that's it. So I import it, and then I'm going to create a repo here, or excuse me, a directory here, a temp directory, to show you that this is a real live running code. So let's zoom over here, and we're going to go check this out. So I got to move zoom out of the way so I can see where it is. And in my temp directory, I have, did anyone remember what that was? 755. Let's see here, 755. Okay. So pop over here just to show you the proof. Let's actually do it in a terminal. I think it's a little bit nicer view. I'm already in my shell. I don't need to do that. So we're going to just pop over, and it is in notebook. Temp directory, CD 755, oops, there we are, LSLA, it is empty, right? Just again, prove nothing up my sleeve. Here we go. I can't zoom in there, that's annoying. All right, so the first thing I'm gonna do is create an ML object. And inside that ML object, I'm gonna create this data, I'm gonna cast it as a data path object. And data path is just what I defined here. Now, again, it can be cast as anything you'd like, and I'll show you doing that in just a bit. But in this case, I'm going to do it as a data path object. So now I've created it, and then I'm going to go forward. That's all that's required for me to instantiate this as an object. So here, for example, I'm assigning a run ID. Here I'm assigning a step ID. It had to be a UID. Here's I'm assigning the date. And now I'm going to intentionally make 3 errors. The first error I'm going to make is data store. I'm going to set it to none. And as you can see here in my schema, data store was required and could not be empty. I'm also going to set it to be AWS blob object, which is wrong, as we saw here. It needed to be AWS blob. And then finally, I'm going to leave empty that nested field that you saw there. And now when I go through and I try and save it here, you can see I get real human errors, right? So connection, endpoint may not be null, storage connection must be one of this list, and data store may not be null. So here, right here, just as a data scientist, I'm able to interact at a level that I understand, and the response is empty, but the errors are correct. So now I'm going to go through, I'm going to correct my errors. Data store has a value, data storage connection type is AWS blob, and the endpoint has this store, Titanic store over here. I hit save again. I see no errors, and instead I get my file path, which is here. Let's go over. We saw that it was empty before. I hit list again, and there it is, right? And if I go and I click on that just to see what's inside, you can see here, I double click on it, and there it is. So now that object that I had written, again, just using native Python, has now been written to a YAML file that I can move forward, right? And so now a data scientist may want to go forward. So now, even in the same notebook, I've now recorded that metadata. But even if I was in a new file, I could get that object by doing nothing more than handing that path. So here I'm going to create an object from a file. And if I print endpoint there, you can see that I got that. And again, just to show you that this is real live under the hood, I'm going to go here and say, just to prove that it's real, and I go back over here and I'm going to reload that object, and you can see it read it in correctly, right? So now I'm operating at a Python level, but I'm able to natively interact with metadata that I'm writing to disk. Continuing along, these can be quite complicated, as you see here. Here's an entire way to roll out a training against IBM Watson, for example. Quite complicated, but the ML spec lib supports all of it. Here's nested ints, here's lists. You can attach an entire dict if you'd like. Here you can attach a multi-line script. And again, all this metadata can be read and written natively from my Python. And it's always nice when your code catches you and does work on your behalf. If I was to hand this to you and say, find the bug, there is a bug in here, it would take you a long time. I did this, and it told me, this actually happened in real life, not exaggerating here. I misspelled container, which was up here, right? Good luck finding that. But it caught it for me, and now I do it, and I go and record it, pop back over here again, just to show you that it's real and live, and off it went. So now I'm going to continue forward. Here's, I always hate when libraries can't extend out. In this case, many of you, if you're like me, have, standard Python scripts that take arguments. I'm going to take this object here and just serialize it to YAML, and then hand it to this Python script. And the Python script's going to execute. Now, it's mocked behind the scenes, but this is a real live script otherwise. It takes that YAML in and then executes a training run. That's very, very fast training run. Come use Azure, we're that fast. No, we're not. It's because it's all mocked up behind the scenes. But I, as a data scientist, don't care that the library, that the web service that I was interacting with didn't understand that. All I know is that it handed me back this information, and I need to record this. So I got this back. It's a dict. I instantiate my own ML object called train results in this case, and I'm going to assign the results of that dict one at a time here to that object and then save it. And now when I go look at that directory, you can see there it is, training execution and training results. So now I've taken that thing that knew nothing about the library, knew nothing about the metadata or schema that I cared about. I translated it in just, 10 lines of code. I was able to convert it into an object that was useful for me, especially for recording that into the future. If you're like me, you hate writing conda files. Here's how many lines of code it takes to write a conda file in script. Again, well structured. And when I save it, off it goes. And you can see there's my conda file. In this case, written to metadata. Now it's all writing to disk. Obviously, it's trivial for me to hand it off and send it into the cloud somewhere else. But I'm just writing it to disk for now. Let's say that I'm lazy and I don't know what fields are required out of my schema. I can just do, instantiate the object and then just like validate, and it'll tell me it. Let's say I'm incredibly lazy, as I said before, I am incredibly lazy, and I wanted that entire Watson run config generated for me. Presto, right? I hit this, and it now spits out an entire block of code with the equal signs and everything, and all I have to do is go through and assign the ones I want. It also says what's optional, so I can go through and assign those, or just delete them if I don't want. And off I go. Okay. Any questions so far before I get into a little bit more advanced stuff?
Feedback or thoughts?
Okay.
I have one quick, sorry, my name's Evan. I do have a quick question. So I think I see on GitHub, like you have schemas saved, but do you imagine normally that like within a project or maybe within a company, like
yeah, that's what I see more often than not. A company will define its own schema. Now, let me tell you, I have a secret hope that we are able to, as an industry, come together and establish a standard set of schema across many different things. Now, to be clear, I'm not expecting everyone in the world to adopt, I don't know, take your random pick here, that training params should be an S and not, ETRES or something like that, right? Like, sure. Everyone's going to be different. But if we're able to agree that, hey, you know what, for better or worse, everything in the world should have run_date associated with it. Just agreeing that there should be a training execution metadata type, and it should have run_ID in it, and everything else in that file is optional. Just that, for many different steps, I think will be transformative for us as an industry. And let me point you all at a wonderful paper called ML Schema. Paper. Here it is. So this is a paper that I think covers a lot of what I'm interested in. It's not, this was done by a number of researchers in the past few years, where they built a very interesting ontology of standard ML objects. Now, again, like I said, I'm not saying this is universal, but if we agree that everything, for better or worse, everyone's going to have the concept of an experiment or a run or a data set or a feature or something like that. If we just had shell schemas for most of these, then I think thank you so much, Alyssa. Then I think we will be in a much better place than we are right now, which is, unfortunately, I've seen all of this, like there's study, there's project, there's experiment, there's group, there's blah, 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 blah. But they're all the same thing, they're just named differently. So I think that we should do something. My hope is that by writing simple tools like this, and then ideally maybe we include some defaults in the box, it helps to like start the process flowing. That makes sense?
I think that's smart. Yep.
Okay.
I have a reverse question.
Yeah, go ahead.
But actually a question to people who are on the call, and I'm going through the list and I know quite a few of you, and you're all working in various places throughout the industry, probably facing these types of issues. Anybody's willing to share what they do internally or anything that's been hand-rolled internally and deployed to alleviate this problem? Curious. And if not, then that's good too.
I can share about a past company. So we ended up also using Marshmallow for a lot of this type of thing, and then used Marshmallow Data Class, which is like a helper library that that helped us solve the problem of, I think, similar to ML SpecLib, at least giving you one place to authoritatively write your schemas. And then in that case, it was like a data class, which are sort of data scientist friendly. And then you could generate a Marshmallow schema for validation, and then also use like OpenAPI or API spec to generate the. Yeah.
These are all like wonderful things, and oh, sorry, I didn't mean to interrupt. Were there others who wanted to chat? Pardon me, I'm looking for something.
Thank you, Evan. Anybody else wants to chime in?
Yeah, so Brett Tully here. I work over in Australia at a company called Nearmap. There's actually a really well-timed talk for us because we're doing some very large pipelines at quite large scale, and we've actually been hand rolling a lot of these metadata classes based off JSON schema. We looked at Marshmallow, but we need to interact with a few non-Python teams, and so that was a bit of a challenge for us using Marshmallow.
Yeah.
But yeah, this looks super cool.
Yeah, it's so fascinating. And don't get me wrong, I don't want to take anything away from these folks. The funny part is, like, I almost always ended up at the lowest common denominator, which was like YAML or JSON. And the basic reason was because every language knows how to read and write those. So absolutely, I've heard that exact same thing.
Do you see, you know, once the open source community comes together and starts contributing to this wonderful effort of standards creation when it comes to schema and metadata, how do you see this evolving for other languages and other tech stacks that are not non-Pythonic tech stacks?
Sorry, is that for me?
Yes, David.
Oh, so the standards for standards' sake never work. Never. They always need to be anchored in a use case. And so Brett is a, you know, not to call you out, but Brett is a perfect example. Like, without the building these large pipelines, you would have no need for metadata. You were like, standards, blah, you know, it's just not necessary. What ends up happening, I've seen this happen many times, is you get you build a structure, the structure has value, you share the structure back, then more people see the structure and see value in that and contribute, and it becomes, that's what ends up becoming reproducible. My thought is that, you know, Python is the lingua franca for the industry that we've chosen to work in. So for better or worse, I think we're going to be using that for a while. Should there be enforcement of these things for things like Go and Java and so on and so forth? Absolutely. But I do want to be clear, right? This library is so thin. It's so little work, right? For me, I would probably, if I was building a pipeline, a complex pipeline, I would probably just stick this thing in a container with, you know, a simple file that like read it in, enforced it, and then spit out, you know, 0 or 1 as to whether or not it passed, right? Like you shouldn't think about having to necessarily build this into everything. And it's interesting. I do hope that Victor joins us, because one of the things that you know, they were doing, right, was literally as part of the container and the MLBox and things like that, they're using this to do nothing more than schema enforcement as they read into MLBox what's going on. And that's very much what I envision here.
I have a quick question, David.
Yeah.
If I could chime in.
Yeah, of course.
So I do MLOps and DevOps for the company I work for. I work for PSEG in the East Coast. So I do a lot of IT operations for them. So I build a lot of these pipelines and stuff. So one question is for Python since machine learning is mostly done with Python and AI is done with Python, would you recommend using virtual environments for that? Because most of our pipelines that we do create with using Python, we create it using virtual environments so that it's easy to containerize them. But would that be something that you would recommend even for ML applications? Because we are starting with Data Lake.
I would absolutely never do any machine learning without using a virtual environment. Never.
Okay.
Not one line of code without a virtual environment. Like, you cannot imagine how bad and conflicting and troubling various dependencies are in machine learning. Your data scientists will violate every rule that you lay down to use the latest version of TFX, blah, blah, blah. And that, I guarantee, will conflict with something else that you have. Virtual environments are the only way to do it.
Okay. All right. Thank you.
Yep. Somewhere is the model management working group in Kubeflow. And I highly recommend you joining up there. I swear to God, it's, man, this is very dangerous. browsing my personal, what do you call it here? All right, well, I don't know. Alyssa, maybe you can find it. It's you're looking for the model management working group, and then we'll go from there.
I'll look for it if you want to proceed.
Yeah,
It
should be in the go look at the Kubeflow event calendar if you wouldn't mind. It should be in there. Okay, so we're going to go a little bit further here. So I'm going to show you one more thing. You asked about extending it earlier. Here, I'm going to try and create like a ResNet benchmark. I did some work with MLPerf to use a type enforcement system with them. And here you can see this is intentionally failing. It's actually spitting out a stack trace that I keep meaning to make prettier. But the reason it's spitting it out is because it doesn't understand what this context is. So here, I'm going to import from external schema / MLPerf. So that default class wasn't there. That default type wasn't there. I built this in a different directory here, and imagine that it's some external schema. Pretty straightforward stuff. Again, just using the standard language here. And when I pop back over and I append it to the path, it now works properly. And you can see here it generates it and does it also with type hints based on that schema, saying this has to be an integer, this expects a float, and so on and so forth. Here's using lambdas. This global batch size is supposed to be larger than 3,000, or excuse me, larger than 4,000, greater than or equal to 4,000. And you can see there it gives me an invalid value. When I go through and fix it, it works fine. And then, like I said, finally, now that I've saved it, it's trivial to load. And you asked earlier about what it might look like to save it. I'm working on extending this to using graph databases right now. Here, Cosmo offers a graph database, and this is experimental only. But you can imagine that MLspec lib saves directly to a graph database. And unfortunately, that doesn't work there because I made that up. But you get the idea. That said, I probably would like the project not to include this in the core. I think it's much more appropriate to write these to a separate file and then have those files extend out and push into whatever system someone would like. Okay, and so that's the end of the majority of my stuff. Like I said, here's the project. You're more than welcome to join up, mlspec-lib. I also have a bunch of examples in here. I built some GitHub actions around it, some utilities. If you'd like to have a Docker container that has MLspec in it, you can do that too. And just to show you what this looks like in an MLOps pipeline, thank you, Alyssa. You can just pip install MLspec lib, but an MLspec pipeline might look like this. So, here's the directory. All you have to do is store a bunch of schemas in a very standard structure here, and you can go. But I created a very trivial pipeline. Here, here's what I was saying earlier about like if I wanted to store it off at a into a graph database or something like that. Don't worry about that. But the point is that, inside of each of these steps, and I'll zoom in here for a second, inside of each of these steps, you have this is GitHub Actions. I have an action here, and, I can store it off to Metastore, but here's the most important bits, where I'm saying, here's the directory for the schema, including a Git URL. So I'm pointing this action at that schema over there. And then inside that, here's the parameters file for that schema, meaning this is the schema for the inputs for a given step. Here's the schema for the execution of that step. I think that every step should have inputs, executions, and resultant outputs. And here's the file that will actually be executed inside that. Now, again, this is just my idea of it. You can structure your actions however you'd like. But by doing it this way, I'm able to go through and check a bunch of things. And again, this is just the open source thing that I wrote. Nothing interesting here. This is just a sample action. I wouldn't say you should copy this, but it may give you some ideas. But in it, you can see what it does first is, you know, I just spit this out myself. It downloads the schemas, it appends the schemas to the registry. Then it loads a bunch of workflow files in to understand what the inputs and outputs are. And then it enforces a bunch of these schemas, you know, down the line. And here you can see I can execute it and so on and so forth. Now you're saying, well, why would you do all this? The reason is because it's so easy to make mistakes. The point of part of this is, how do I avoid making mistakes, especially from an automated perspective? So in this case, here is one of those schemas, you know, just like you saw earlier. And if I go in here, you know, and I make a very simple error, for example, sorry, I have to just move some stuff around here so you can see it. Let's say I forked this and I add it together. And instead of typing run, you know, CPU per node, I say CPU per nodes, right?
David, can you increase the font a little bit?
Yeah.
Sweet.
So instead of typing CPU, you know, here's what it should look like off the bat. Let's say I make a mistake and I type CPU per nodes and I add an S there. You know, so easy to make that mistake. No one, you know, unless you were, you know, part of the core team might notice that. I hit commit, and it's going to automatically kick off that pipeline. You can see the action taking place here. And, you know, that's automatically kicked off from that metadata, running the full workflow. It takes a little bit to run. So I'm going to show you what happened earlier, which is it caught that error at exactly that phase and showed me the exact results that I had made a mistake on. And again, that's the value of having schematized metadata, is being able to programmatically catch those mistakes and take action on them, rather than having it go through your entire pipeline. And so with that, that's the total of what I have here. It looks like we missed Victor, so unfortunately we're not going to be able to demo that. Yeah, I'd love to just open it up for questions at this point.
Thoughts, feedback? Yeah, sadly, I was not able to get a hold of Victor. I hope he's okay. He owes us another talk on another day.
Agreed.
David, I have some more questions.
Oh, sorry. You go, Evan.
I already asked a question. Okay, fine. So two questions for you. One, how deliberate were you in making the, like the attribute assignment syntax to be like the dot notation assignment? And second question is, what's your philosophy on how like reversible the metadata should be? Like in your pipelines, do you think that like everyone should be logging, I don't know, random seeds and stuff that are not necessarily like input, they're not deliberate or conscious input parameters, but they're like actually required to reproduce values?
Yeah, you bring up such an excellent point. You know, the problem, of course, is that machine learning is ultimately stochastic, right? So you're gonna run into issues getting perfect reproduction no matter what. That said, recording as much as you can know about at the start is your best bet. You know, random seeds and things of that sort, you know, ultimately those are going to be components of your model that are pretty much resolve similarly. So it's not the end of the world if you don't. That said, if you know it, you might as well record it, because what's the worst that could happen? All that said, you know, the schema, everything is designed to be extensible. The reason I intentionally chose dot notation is I just feel like it is less error prone for building these kind of pipelines. You can have Python introspect much more easily into dot notation things. And to be clear, I do a bunch of hacky shit behind the scenes in order to like get you to do dot notation and use Marshmallow simultaneously, because the two don't overlap together. Again, I would love nothing more than to have someone come in and tear out tons of this code and make it better. But I just felt like, especially in things like VS Code and PyCharm and things like that. Dot notation is IntelliSensible and predictable and things like that. And using index keys into dicts is not. And so that's why I chose what I did.
I have one more question, if you don't mind. Yeah, this is fascinating to me. Have you thought about, or maybe in your other lines of work, have you thought about making a distinction between elements of metadata that like should invalidate the output with respect to the downstream task, as opposed to like I picture an example of Luigi back in the day using Luigi,
Yep.
and
Yep.
you would actually explicitly define what it meant for the target to exist of the task of the target rather.
Yep. So yeah, that's a wonderful point, and something that I think that way too many machine learning scientists and data scientists don't pay attention to right now. You ideally, programmatically, you are able to describe the outcome for an inference at the end, the success criteria at the end. Otherwise, you will fall into a trap that many scientists fall into, which is kind of like hacking your way. They call it p-hacking or things like that, but basically where you are hacking your way to a result without predicting what your hypothesis, without detailing your hypothesis, right? And so you'll get something that gets to whatever 98% accuracy, but you didn't predict that, so that could easily be random, right? I am not a dynamically typed language fan. I'll be honest with you. I think everything should be strongly typed. I think compilers are very good at doing what compilers need to do, and we should use them for that purpose. And what you're seeing here is intentional, right? The default of everything you saw here is that everything is required and cannot be empty. And if you don't think it's an important, attribute, then don't include it. That said, it's not exclusive, right? You can, as you saw, you can attach a dict. I cannot introspect into a dict, right? I have no idea what you're going to stick in there. Enjoy, right? You can add any optional parameters you want. But my recommendation is the extent to which you can stop things, programmatically, the better off you are. Now, I want to be clear. Too much information, too much noise is just as bad as not enough, right? If you are paging someone, every 5 minutes, they're going to hide their pager. So it is up to you to balance that. But I'd rather have the tools to catch it and then turn the noise down a little bit than not have the tools at all.
Yeah, cool. Thanks so much.
Of course.
How production ready do you think this is?
Well, I don't know. First off, I'll be honest with you, right? I'm one dev. There's no chance that I don't have bugs all over the place. That said, the QPS for this is, of a production system for something like this has got to be queries per second. That's a Google term. It means, how busy your thing is going to be. It's going to be like, I don't know, 0.00001, right? Like, how many times during your pipeline are you going to check the metadata? What?
David, you broke off. Yes. Can't see you now. But that
very
was very dramatic.
Yeah. But honestly, what what you saw there, all that iteration into loops, right? That's just a Python object. You're just assigning things. Anything that you can do in Python is there. The only time you touch the library is when you read something or you save it. And even if this fails, what's the worst that happened? You have something that you wrote, which is unverified, which you didn't have in the first place, right? So I guess my take is it's such an optional portion. I would never, ever, ever put this as part of your critical path. Meaning like I wouldn't have every query that came in get sent through this library. I have no idea whether or not it's appropriate for that. I can almost guarantee it's not. But that said,
I guess I was more thinking about the stability of the library itself and the
I mean, I don't know. Like I said, I'll be honest with you. It's if you pinned the library today and we tore it apart tomorrow, and every interface changed, I would just keep using the library pinned to exactly the version it's at. Like, honest to God, there's no reason that this library wouldn't be good forever at its current version. That said, it is definitely my hope that I'm able to find folks to support, be able to import and export JSON schema, because that's something we get quite a few requests for. Be able to read and write Open API. It's another thing we get a lot of requests for. I think I definitely do some contortions behind the scenes around Marshmallow and things like that I probably should be a lot more streamlined around. But I'm not going to know about any of that stuff until people start using it. And this is honestly, it's first coming out. So I'd love to hear what people think.
Cool, thanks.
What else?
We have a very shy 38-person group here. Aside from Brett. Brett, by the way, are you in Australia?
Yes.
Insane. So we are definitely going very global with this meetup. Thanks for joining.
No worries. There's a few of us from Oz that are logged in at the moment.
Sweet.
Hey, David, do you know if, I don't know how much you looked at Metaflow?
Yeah.
But they seem like kind of different in a lot of ways than, I mean, I know they're not quite comparable to what you're doing, but do they have a metadata serialization?
I'll be honest, I have looked around a lot for something like this. Most folks that I've seen end up just going with the generic frameworks. And I get why, right? Like you look at something like Marshmallow or JSON schema and things like that. And there's nothing wrong with them, obviously. I just felt that the biggest pain here is getting data scientists to actually use it. And if you didn't build a library with that in mind, that Python first mindset, you were going to have limited adoption or limited usage. Nothing makes my heart sting more than when I go to a customer and I tell them about this thing and they're like, oh my God, I used it and it literally saved me, 12 hours of, figuring out how to rewrite YAML or, verify something. That's a dream statement for me. I think much more sophisticated frameworks, internal teams as well, often have done this themselves. They've written their own parsers, they've written all those kind of things. But I'm always astounded at how many people don't do this. So I just came from Google, and the TFX pipeline, which is very, very heavily used internally, only has two core schema, right? An execution and an artifact. And then it's up to teams and pipelines and things like that. Often have to go and write their own stuff that are relevant for them. I never understand that. I feel like building some structure around this is so powerful. And especially at Google, I find it very funny because, they are the ones who really created or not created certainly, but they popularized the use of schema around RPC objects, right? With gRPC. You're like, why aren't you doing this over here too? I don't know. I could never figure it out. And my best guess is basically because everyone hates standards. Everyone's like, oh no, if you do this, you're gonna constrain my creativity. Bullshit. We're not gonna constrain anything. We're just gonna say here's how you do it, and then magically stuff happens. So I don't know. I can rant about this for a while.
I have a quick question. I'm a bit new to the whole ML side of pipelines. Yeah. Is there a point where you can realize that the metadata that you have is actually not very good? Could you come to a point where you're like, this metadata I'm using is absolutely shit. I need better data because everything just looks like, like crap, like there's outliers, like, or things going quacks.
So let me double click on what I think you're asking, which is not, you're actually curious about the data, not the metadata.
Yes.
So one thing that we also as an industry haven't done a great job of is explaining to people the value of metadata about data. Those are two different things. And a common thing to go and describe is like, well, tell me the schema for your data programmatically. Tell me the structure, the statistics about your data. Generate some examples for your data. Generate the range for your data. Again, to use trivial examples, you should be able to detect, you should be able to tell me for a given field, for a given data, how many zeros or nulls there are for a given column. And I mean, that's just basic, statistics. You should be able to say the range of that column, right? Like, here are the appropriate values for it programmatically, right? Like, if you have an age column, it's probably not appropriate that there's an age of 200 in there, right? Or -1, right? Like, you need to programmatically describe those things via schema, via statistics, via all these kind of things, because you will use that later. You will use that both during your data processing, your feature engineering, your training, and ultimately your inference. You're going to use those same statistics and schema to confirm whether or not things are working appropriately, because otherwise your model is not going to be relevant. So that's something we really don't talk enough about. Metadata about data is incredibly important and goes throughout the entire pipeline, right? And I hope my library is used to record some of that. I would also say, don't try and invent those things yourself. Go and use TFX has a very valuable thing called TF Data, which does a number of this generation on its own. It has TF schema or schema gen, it has data gen, it has example gen, it has all these various things for looking at CSVs. Unfortunately, I think they actually also support. I think they support Parquet files now. I can't remember, but they certainly support CSVs. And they can look at a CSV and describe, the rough schema of this, and generate examples and things like that. And those kind of basic tools are incredibly important for building reliable pipelines, because you can't say whether or not your data is appropriate or not programmatically if you have no structured way to say yes or no. If it's always going to be just a human being saying it, you're always going to get it wrong. So my recommendation is, it's trivial to say, but if you want, mentally thinking, what would it look like for you to build a unit test against a column of data, right? And build as many of those as you possibly can as a starting point, and then go from there.
I spend my living, breathing time doing exactly that. So if anybody wants to nerd out on logging and validating statistics of the data that runs through pipelines, ping me. I'd love to do that.
I just wanted to call out Great Expectations. There's a Python
library
love specifically built for that exact thing.
Yep.
Just a quick thing. I mean, just a follow up to what we were discussing. Let's say now that we do all of that. Is there a way in the pipeline to actually, I might be going a little far off, but is there a way in the pipeline to actually check for the data or to see if the data is clean in some sort of way? Because I know that so I've done deep machine learning, that's my background, but you can do that in those kind of ML formats, but could you do that in pipelines? Like that's like would be a next step, like if you could do that, that way you have checks and balances as well as logs. So basically you can always go back to your logs and be like, okay, where am I going wrong kind of deal.
So I think I might be, so the way you would do it is, one, you would say, unless the verification of this file, unless the unit test against this file is present, fail. right? That's your first step.
Yes.
Second, once the results of the unit test are there, you use, I mean, arguably, you use something like MLSpecLib to validate that the presence, it's not just present, but the schema is there. All the fields you were expecting are there. They have the appropriate values in them, so on and so forth. And then, now that you've built that and you're able to parse it in, you take that and you run a simple unit test against it and say, I was expecting for this field that everything was in this range, full stop. Did it pass? Yes or no? And so on and so forth. And in that case, that's where you want to use something like Great Expectations to generate that metadata result. And then you want to build a very simple unit test framework in your pipeline and say, here, I'm going to create a very simple pipeline to load this information in and confirm that it's appropriate.
Okay.
And you can also ingest that and monitor it over time.
Absolutely.
For cases where perhaps it doesn't trigger the unit test, but you just want to see how data evolves.
Yep. And so for those that don't know, Alyssa's an expert at this, but like one thing that you want to do is you want to continually be sampling from your inference endpoint, whether or not it's batch or live inference. You want to continually be sampling from that. And so every 100th or 1/1000th or something like that, you take the data that you're getting in that inference and you're sticking that off against, you're validating that against your unit tests. Now, every one of those don't have to pass, of course, but what you're looking for is to make sure that you haven't seen drift from the statistics that you evaluated earlier in your pipeline. Does that make sense for everyone? Because what you're looking for is like, maybe, you built a weather app and you expected everything to be between, 15 and 30 degrees C, right? And then all of a sudden it became summer and, now everything is 25 to whatever, 35 or 40 if you in Australia, right? It goes up and up and up. You don't know, that entire population has shifted. Your model may no longer be appropriate. And that's a trigger for you to go and retrain or change your evaluation or whatever it might be. But that's not even where it's invalid. That's just where things drifted enough that it makes a difference.
Seattle weather models are drifting right now.
Seattle's weather model is easy, right? It's like 18 year round.
No, is it even 18 today?
Yeah, fair. Excellent point. What else?
I have a quick one. Can you hear me?
Yeah, go ahead.
So you touched based on the storage of metadata. Can you elaborate on that? Because the way I'm looking at it, even from adoption perspective, it would be so convenient to do pip install MLSpecLib and then go somewhere and do file new metadata blob for your project so that multiple actors participating in pipeline, and it's inevitable that there are multiple actors in there. Someone is working on data prep, someone is training the model. They can all refer their notebooks or their environments to that shared metadata storage and don't have to worry about exchanging files or creating something artificial, because that one, I mean, it's my wild guess that standardizing on that one is even easier than standardizing on a schema for basic ML operations. So what are your thoughts on that?
Well, so let me try and understand that just a little bit more. My recommendation is metadata is immutable. So you write the metadata once, you can read it infinite times, but you never change it. And so once you think about it from that perspective, you could certainly just make a copy and add an additional attribute. But having that immutable record is what's key. And so an immutable, again, a lot of that depends on how much metadata you have. It could spin out of control, but honestly, like I'd rather record too much about metadata than not enough. So I guess my take is you could never have multiple actors on a single metadata file. You could have multiple readers, but only one person writes, and they only write once. Does that answer?
We deviated a little bit. I absolutely agree that it is immutable. The question was actually a little bit lower level.
Okay.
I was wondering about the exact, literal exact place where you want for this metadata to be stored. Because as people are writing and contributing to that, even as ML pipeline executes, ML pipeline is very distributed by nature. You want to refer to something where the metadata exists.
So I messed around a bunch looking at graph stores. I generally like them, but like graph stores are really hard. Oftentimes, what I have found is the cheapest and cheerfulest way to accomplish this is to have to write the entire metadata object as a blob. Often is something like a document DB with all the attributes, indexable, but having a single attribute that that describes the run that you're in, and then you kind of like you're going to need to record your DAG somewhere, your graph of your overall flow somewhere, so that someone downstream can say, oh, give me the thing upstream from me, or you could just pass that around. But I've found that something as cheap and cheerful as that is fine. But SQL works too, right? Like, it could be a SQL database as well, all with that primary key of uniquely identifying what this run is. But that's how I normally structure these kind of things. I'm doing a bunch of exploration around that right now.
Yeah. So, but and going back to one of my other points, do you think it would help if some of the recipes for those data stores would be included with MLSpecLib, so people can pick one of those or implement interface and have their own storage?
Absolutely. Come join.
Okay, so let's connect on that. I have some thoughts, some more thoughts.
To be clear, as I said in the talk, I would actually like things like that to be outside the core of the library. I want the library. There is some experimentation in the library right now, and I actually keep meaning to tear it out. I really don't want. I want the library just to be give me an object, read it in, write it. That's it. It's up to you to take the output and do something immutable with it. And I would love to have recipes and examples and things like that around that, but I don't want that to be in the core of the library because, as you all know, there's like infinite sources out there for reading and writing to, and I would be hesitant to try and spend a bunch of time working on that.
That makes sense. Thank you.
Speaking of contributions, David, I know, well, first of all, this community, I'm all about bringing people together to think about standards and to build solutions together. And I know that you're looking for people to collaborate with. What's the best way to connect, to get engaged?
Yeah, look, my take would be start with going into the repo, messing around with it yourself. Tell me all the ways it is like deeply flawed, and just give me some issues first. But absolutely, download it, mess around, compile, say like, how could you do this? I'm sure there's a million places I didn't comment properly. It doesn't support this. I'm not even sure. Like, I think I broke JSON parsing recently because I never use it. I did do a bunch of unit tests, which is so rare for me to actually do actual unit testing. But it does have a ton of unit tests that pass and so on and so forth. So, that would be the best first step. You can always email me directly. My email is all out there. I'm on Twitter. I'm on Aronchick@gmail.com. You're more than welcome to send me an email directly or whatever you like. But just jump in. Honestly, the first way to do collaboration is just to try it out and give me feedback. I promised to pass this along. Here is the community calendar for Kubeflow. Do take a look at it. We actually had our meeting today. This is where we're talking about, several of us, IBM and Google and myself from Azure and other folks are talking about schema types that we're trying to develop over time. Kubeflow certainly needs them, and they're doing a bunch of pipeline work there as well. And so it's kind of up to us to figure out how, what we want to invest in and all that good stuff.
Sweet. Anybody else has any questions, thoughts? I know it's almost 7 p.m. We've successfully ran this full meetup without Victor. I hope Victor's okay.
I mean, me too.
We'll
This
have
is
to
so unlike him. I
start
have no
this.
idea what happened.
We'll make sure that he comes back and do this again. But yeah, if anybody has any more questions, I know it's kind of Thursday night. I don't know. I see a few people actually joining from the East Coast, which is amazing because there it's real Thursday night. Australia too. That was a big surprise. All right. Well, if nobody has questions, we will wrap this up.